Good afternoon and welcome to part 3 of our Algebra 1 final exam review. We're in this unit this video, we're going to cover statistics, systems of equations, and exponents to get us all set for our final exam. So starting now with statistics. So in this particular question, we have a scatter plot. We show the relationship between the height and weight of several people. A trend line is drawn to show the general pattern of the scatter plot. Our question here is describing the correlation of the scatter plot and explain our answer. So with information that we have present with us, we really just have a trend line, we have some points, but note that all of these points are very close to the trend line. This is a strong positive correlation. Points are close to trend line. Okay. Write the equation of the trend line in point-slope form by identifying the slope and a point on the trend line. So in this case, the way the trend line is drawn, let's find a couple of points we can get the slope for. Let's say we have, this point looks pretty good that we can use, and I would say also this point here is a pretty good point to use to determine the slope. So the change in x is 4, so that's our 4 on the bottom, and the change in y is from 200 to 230, so it's 30 over 4. 30 over 4 would be 7.5, so the slope is 7.5. And then if we pick a point that's on the trend line, we can pick either of the points that we just identified, so we'll use y minus 200 equals 7.5 times x minus 76, and that is our equation. They want it in point-slope form, we can leave it just like that. Number 50, they would like us, however, to convert it to slope-intercept form, so let's do that. If we multiply 7.5 on both sides, the right side, y minus 200 would equal 7.5x minus 76 times 7.5. That I'm doing on a calculator right now, 570. And then if I add 200 to both sides, y would equal 7.5x plus 770. That would be our equation in slope-intercept form. Next, what does the slope of the trend line mean in the context of the problem? Well, since weight is the y-axis and height is the x-axis, 7.5 means 7.5 pounds per inch of height. So basically, if somebody grows an inch, they would gain 7.5 pounds on average. The y-intercept of the trend line means in the context of the problem. All right, well, the context of the problem, I just realized I did the math wrong on that, by the way. So let me try one more time. 76, 570, 200, trend line, adding 200 here is 370. My fault. Based on that. And I still don't like the way that's written. Why is that? Why did that work out wrong? Oh, because it was negative. Adding. Okay, so just correct the y-intercept there. And then we have the question of the trend line in the context of the problem. Basically, if you had 0 height, you would weigh negative 370 pounds. So there's really no explanation here. It is actually something that's impossible. So technically, 0 height would equal negative 370 pounds, which is not realistic. So in some cases, our trend lines don't really work out to realistic scenarios, and that's okay. All right, predict the weight of someone who is 68 inches tall. So this means here we're going to use x for 68. So if I did 7.5 times 68 and then subtracted 370 from my result, that would be 7.5 times 68, which is 510 subtracted by 370, so it would be 140 pounds. Okay, so if somebody who is 5'8", according to this trend line, would be 140 pounds. If I look back at my graph, that kind of makes sense because it looks like we're making an extrapolation. These are all very tall people based on this graph. Okay, next question. Science class, Timothy collects data, relationship between temperature and pressure for a gas that is heated in a closed container. Temperature is measured in degrees Celsius and pressure in kilopascals. After graphing the data, he notices there's a linear pattern to the data, so we added a trend line. What is the correlation in the scatter plot? Once again, here we have a positive, strong positive correlation due to the fact that the points are close to the line. Okay, find 2 points that are on the trend line. Looks like we have 1 point that's on here, right here, and not really much else. I would say let's use this y-intercept as our second point. Okay, so using the 2 points from question 55, write an equation for your trend line. Well, the slope here, I'll use the point that's right here. This is 10 and 70. This is 0 and 20. So the difference in y is 50. Difference in x is 10. So the slope is 5. So with a slope of 5, and the fact that the y-intercept is equal to 20, we can say 5x plus 20. And so that would be that. Next, predict temperature in gas degrees Celsius for pressure of 14 kilopascals. Kilopascals are on the x-axis. So explain how you find the answer. Here we just plug in 5 times 14 plus 20. That's going to be 70 plus 20, which is equal to 90. So in this case, the temperature would be 90 degrees Celsius. Predict the pressure if the temperature is 45 degrees. So here we have a couple of ways we can do it. The best way is just to plug in for y. We go 5x plus 20. In this case, 5x would equal 25, which means x would equal 5. So in this case, the kilopascal will be 5. And if I look at my graph, it makes sense. If at 5, 45, pretty much good here. So I also could use the graph for this example as well. Okay, next. Finding the following descriptive statistics about this set of data. So in this case, here's what I'm going to recommend for you to do. If you plug in these numbers into either a graphing calculator, Desmos, Google Sheets, Microsoft Excel, any other spreadsheet, different software, you can plug all this information in and you can get what all of these statistics are. But for purposes of this video, let's show one, and then I will show the answers to the other two rather than go through the answers to all of them. Let's just go ahead and write all these out. Okay, so with number 59, the easiest way to get the median and the IQR and the mode for that matter is to sort all of the data. So if I kind of start with here, there are 10 different numbers here. Let's start with the lowest of those numbers, which in this case is 22. And I see I've got a 24, a 25, a 25. I've got a 28, a 29, and I've got a 48, a 57, and a 70. I'm missing one value. What did I miss? 33. I missed 33. So 33, 48, 57, 70. Okay? I know I could have tabbed over, but that's all right. So our data is all sorted. Now, for the median is the number that's in the middle. Well, since we have 10 numbers, we're going to divide these values through the middle of those. So in this case, the median here is 28.5 because it's the average of 28 and 29. So median is 28.5. I'll do the mean later. The mode, any numbers that are repeated. In this case, 25 is repeated once, and that's the only one that's repeated, so the mode is 25. And then we will have to find the IQR. So we're going to actually have to use the quartiles in this case here. So in this case, the first 5 numbers would form the first half. The first quartile would be right here. So our first quartile is 25. And then over here, our third quartile is 48. So our IQR is 48 minus 25. So IQR equals 23. And then 1.5 times the IQR would be 1.5 times the IQR in this case would be 30, so 35, 35, 15, 34.5. All right. So basically, anything that's outside the median plus this or minus this would be considered an outlier. So our fence, our upper fence, our lower fence is going to be negative. We don't need to worry about that. But our upper fence is going to be 28.5 plus 34.5. That would be equal to 70, looks like 73. Okay, so that's our upper fence. So our upper fence is 73, and it looks like here we don't have any outliers here. Our lower fence would be -5, -6, so obviously we're not there. So there's no outliers in this particular set of data. For the mean, we would just have to add all those numbers, and again, you can use the list feature, you can use the a spreadsheet, you can do, as long as you get all the numbers up and divide by the amount of numbers you have. So in this case, we have 10 numbers. We're going to add all those up, and then we'll divide by 10. So in this case, the average is, the mean, excuse me, is 36.1. Okay. When I added them all up, I got 361. So you can check math if you want, but I'm pretty sure that that works. Okay. So like I said, I'll go ahead and put the rest of the answers up on the screen. We won't go over how to answer all 3 of these in this video like this, but that's the first one, and we'll talk about those after. So I'll pause, and we'll put the answers up right now. Okay, so I put the answers to 60 and 61 here on the board. I would like to also clarify I made a mistake, and I used the median in my upper fence calculation with number 59 just a bit ago. I corrected it now to indicate that you're actually using the quartiles as your bounds for the upper fence. So actually you would use 48 plus the 1.5 IQR to get the upper bound of 78.5. Obviously that's still greater than what you would have had here, and it doesn't affect too much of your answer too much, and I also realized I forgot to correct the upper fence number as well. It's 82.5, my fault. So that fixes that. And then also here with 60 and 61, you'll notice I highlighted the numbers that are outside of those fences because that's what you would use to determine outliers in the first place. So in number 60, we had a lower fence 13.5, which didn't affect any, did affect one. 1 is less than 13.5, so this is an outlier. Anything higher than 25.5 would also be considered an outlier, but we don't have any of those in this particular data set. Here, 65 and 110 were our fences. 43 was below, so we say that that's an outlier. Okay, now we have systems of equations. So in this case, we're going to be solving systems using graphing, using substitution, using elimination as options. So we have 6 to go through. Actually, we have 8 to go through. So let's talk about how we're going to solve these systems. Okay. With y equals 2x minus 3, y equals negative 3 8/4, and there's supposed to be an x here, 3/4 x plus 8, I just realized. Glaring typo that nobody caught until now. There should be an x right there. Okay, so negative 3/4 x plus 8. Okay, so we're going to graph those lines, and we'll use the slope-intercept form graphing method, which is just using the y-intercept of negative 3, and then up 2 over 1. And so I'm just going to use a skeleton for now of those points to see if any of those points work. Here I have positive 8 as my y-intercept, so I'm actually going to go down 3 and right 4. So boom, 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 over 4, and then I'm actually going to end up right there. I should change the color of those points. Let me do that. Let me use blue for the second line. So here we have, and then down 3 over 4. You'll notice that this particular line, if I draw lines on here, we will get a point of intersection because the the solution to a system of equations is where the two lines would intersect. So in this case, the solution is 4, 5. And also we want to make sure we list both points in our solution. All right, if I were to plug these points in, I should get the same, I should get a true statement for both equations. So if I plug 2 times 4 minus 3, I get a 5, that's right. If I do negative 3/4 of 4, that's going to be negative 3, plus 8, that's also 5. So that works. Okay, with number 63, same kind of deal. We have 2 equations already in slope-intercept form. We'll use the slopes and the y-intercepts to kind of get our line. So in this case, negative 4x plus 1. Negative 4 is our slope, and 1 is our y-intercept. So 1, and then we're going to go down 4 and over 1 to get the next set of points. So I'll do that here, and I'll give myself 5 this way, 4 points this way as well, by going up 4 and left 1. So there's our first line. Let's change colors. We'll go pink for the second line. Negative 2x. So in this case, the y-intercept is 0, and our slope is negative 2. That means we're going to go down 2, and we're going to go right 1. Okay. Now here, you'll notice that we can tell the intersection is going to be somewhere in here, in this zone right here, because of where these lines are sketched and drawn. So let's kind of visually get a line out here. Let's just reduce the thickness a little bit just so we can clearly see what the slope is, where the intersection is, excuse me. And then here we have that line right there. And let's change the color. And we'll go with this line right here. And we'll see the intersection appears to be right about, looks like it's actually right about here, according to this. Maybe not quite there. So this is a little tougher here. The slope, this intersection looks like it's going to be like about half and negative 1.5. So we're going to have to test that out and make sure that works. So the point, I think it works. And here we can always obviously check with Desmos, but since you won't have access to Desmos on here, you can also use a graphing calculator, use the intersect function to do that as well. 0.5 and negative 1.5 is my guess. So I'm going to plug that in. If I did 0.5 here, that's going to be negative 2. Negative 2 plus 1. Okay, so that does not work in that one. Okay, so here, it's a little tougher to get this one particular point here. I know it's not quite that. So I'll use my graphing calculator. If I plug those lines in, negative 4x plus 1 and negative 2x as our lines, I'll use the graphing feature, calculate feature to do that. My calculator, and let's see, we get the solution. Okay, so my calculator actually put close, said I was pretty close. It's actually negative 1 as our solution here. So I had the x value right, but I had the y value off just a little bit. So it's really supposed to be right here, right where those lines are. So just graphing inequalities and like that. Okay, so that's where that intersection should be. Negative 0.5, or negative 1, excuse me. Negative 2 times 0.5 is negative 1. Negative 4 times 0.5 is negative 2, plus 1 is negative 1. So it works. Okay, so the solution is 0.5 and 1. Now, with these, we have sort of an option of whether we can use substitution or elimination. I like to use substitution when an equation is already solved for one of the variables. I like to use elimination when they're all written in standard form. So with number 64, these are both solved for y, so we can just set them equal to each other and solve it like a regular standard linear equation. So x plus 3, and then we're going to say 7x minus 4 equals 3, 7x would equal 7, so x equals 1. So x equals 1, and then I would plug in this x equals 1 into one of the other equations to get my y. So in this case, 1 plus 3 would equal 4, so my solution is 1 comma 4. And then just to make sure that works, if I plug it into the first equation in this case, 8 times 1 is 8 minus 4 is 4, so that solution is good. For 65, this second equation here is already solved for y, but the first equation is not. So we'll use this statement right here into this function for y. So instead of 4x plus 7, and instead of y, I'll write x plus 9, and that will equal 19. So 4x, then I distribute my 7x plus 63 equals 19. 11x plus 63 would equal 19. I'll subtract 63 on both sides. By subtracting 63 on both sides, I will have negative 44, and that means x equals negative 4. So because x equals negative 4 plus 9 is 5, so my solution should be negative 4 comma 5. And just to make sure, 16 is negative 16, this is positive 35. Negative 16 plus 35 does equal 19, and then negative 4 plus 9 does equal 5. Okay. Now for 66 and 67, your better options here are actually to use elimination, especially since one of these is already written in opposite terms. So remember, with elimination, we just try to combine the equations by adding them vertically and lining up all their points. So see how we have negative 2x and we have positive 2x? That means we have 0x there. And then this would be plus 9y, this would equal 0, which means 9y would equal 0, which means y equals 0. So our solution for y is equal to 0. And then if I plug in that number into one of these two equations, I like using, actually I like using the second one. It doesn't matter which one you use, of course. So 8 times 0 is 0, so 2x equals 6, which means x equals 3. So my solution should be 3 comma 0. Okay, and then just to make sure, negative 2 times 3 is negative 6, plus 0 is negative 6, so it works. Okay, and of course it would also work here as well. 6 plus 0 does equal 6. For 67, we can use elimination here, but we actually have to multiply one of the two equations first to get opposite terms. So since I already have a 5x and I have a negative 15x, I actually can just take this first equation and multiply it by 3. And if I do that, that would rewrite that equation to 15x minus 9y equals 66. Okay, so I'll put that right here underneath this equation. We'll strike this out for now to see what we did. We just rewrote this equation times 3, right? So now when I vertically combine these, I'm going to have 0x minus 7y equals positive 63, which means negative 7y equals 63, which means y equals negative 9. Divided by can't type today, by negative 9. So then, of course, now negative 9 equals that. So why don't I go ahead and plug in y equals negative 9 into one of these two equations. I'll choose to use the first equation. So that means negative 9 is right here. So that's going to be 5x minus 3 times negative 9, which is going to be rewritten, and that would equal 22. That'll be 5x minus, technically minus negative 27, so I can rewrite it as plus 27. That will equal 22. Now if I subtract 27, that's going to be negative 5, so x would equal negative 1. And that is that. Okay. So our solution there, once we find x equals negative 1 from that, our solution therefore would be expressed as negative 1 comma negative 9. Okay. So there is that system. Now we have 2 more to go. So same deal here. We've used elimination since this one's already written in standard form. We have 2 options here. I'd say the easiest option actually is just to multiply 2 on for the top equation. That would actually cause the both equations to eliminate, both variables, excuse me, to eliminate. So if I multiply by 2, that's going to be 14x plus 2y equals negative 12, excuse me. And then if I vertically combine these, you'll notice that when I vertically combine them, I'm going to get 0x and 0y. So 0x plus 0y, and that will equal 18. Okay, well, it's not possible for that to happen because this would both be 0. 0 does not equal 18. This is a contradiction, and if we get a contradiction, there are no solutions. So that would actually be your answer to number 68, no solutions. for number 69, we already have a system that where one of the values is already solved for one of the variables. So y equals negative 2x plus 3. We can just take this and plug it into the second equation directly by using substitution. So 2x plus, still caps are still on, negative 2x plus 3 will equal 3. Well, watch what happens here. If I combine 2x and negative 2x, that's 0x plus 3 equals 3, which means that that's 0, so 3 equals 3. This is called an identity. When that happens, we have infinite solutions. Okay, so any point, any xy combination would work for both of these lines. Okay. Now, we have a word problem with systems. Maria and Jack opened bank accounts in the same day. Maria started with $200 and adds $50 per week to her account. Jack started with $100 and deposits $55 per week. Let me just make sure here. Starts 200, adds 50 per week to her account. No, okay, so actually the number of Maria and Jack account same days. Money in the account, I'm trying to think of the best way to define the variables because we actually don't know the time. And we don't know the bank account amount. That's the information we don't have. So we don't know how long they've had the accounts open, and we don't know what's in each account. So there's actually two separate equations, but we'll use, and it sounds confusing, we'll use the y value to separate to mean both equations. So in this case, the equation to get the money in Maria's account, that would equal, well, since she started with $200 and adds 50 per week, that's going to be 50x plus 200. Okay, sorry, let me move that out of the way. So $50 per week, $200 to start with, right? For Jack's account, his account is basically $55 per week plus $100 to start. Will the two accounts, when will the two accounts have the same amount of money? How much money will they both have? Well, this is really a system, and notice that it's both for bank account amounts, so we actually can just set these two numbers equal to each other, these two equations equal to each other. 55x plus 100 equals 50x plus 200. So if I do that and I solve these equations, solve this equation, I see that I'm going to subtract 50x on both sides. So if I subtract 50x, that's going to be 5x plus 100 equals 200, which means 5x would equal 100 when I subtract 100 on both sides, and x would equal 20. So in this case, they'll have the same amount of money in 20 months. Okay. How much will they have? Well, you can take this value and plug into either of these two equations, and we should get the same number. If I do 50 times 20, 50 times 20 is like 5 times 2 plus 2 zeros, right? So that's 1,000 plus 200. They will have $1,200 in their account. And just to make sure, if I do 55 times 20, that's $1,100, and then plus 100, that would also equal $1,200 or $1,200. So the answer to the first question, when will they have the same amount of money? They will have in 20 months, and then they will each have $1,200 in their account. Okay, so that's that. Next, for the fundraiser, students sold T-shirts with the school logo for $14 and sweatshirts with the school logo for $20. They sold 233 pieces of clothing and raised $3,748. How many of each shirt? How many of each type of shirt? Time of shirt? Oh boy, typos. Typos. Type of shirt. Sorry. Okay. Did they sell at the fundraiser? I did not write this review, just full disclosure. Okay. Define the variables. So in this case, we don't know how many of each type. So let's let x equal type 1, and let's y equal type 2. Okay. They don't really name like what type it is. Sweatshirts, T-shirts, and T-shirts and sweatshirts. So T-shirts sold, and y equals sweatshirts. Okay. Write an equation to model the total number of shirts sold. Well, we know that they sold 233. So if you add up the two numbers, we should get 233. So there's our first equation. And an equation to model the amount of money that was raised. Well, in this case, they sold the T-shirts for $14. So if I did 14 plus times x, plus 20 times y, that would equal the cost $3,748. So now this is a system. These two equations are a system. I actually find with this equation, it's actually a lot easier for you to use. Substitution to solve this particular equation. So I'll write y equals 233 minus x. This first equation, solving it for y just by using the subtracting x, right? So in this case now, the second one, we're going to take 14x plus 20 times 233 minus x. That will equal 3,748. Let's just distribute our 20. 14x plus 233 times 20 is 4,660 minus 20x. and that would equal 3,748. Now if I combine my like terms first, negative 6x, and then subtract 4,660 from both sides, that's going to give me a negative number, 4,660, and it's going to give me negative 912. And then if I divide both sides by negative 6, that would equal 152. So 152 t-shirts sold. That would mean that if I do 233 minus 152, that would give me the amount of sweatshirts that were sold. So in this case, that would be 81. So they sold, is this the end of it? Yeah, that's it, okay? So 152 t-shirts and 81 sweatshirts, okay? Which we, of course, could check and make sure. We could plug this number here, make sure we get that cost. And, of course, these two numbers added together should equal 233. Okay, next. Exponents, okay? Rewrite each expression using your knowledge of exponent rules. Use only positive exponents to write your answer. So for 72, we have x to the second to the negative 9th. So the product rule here would apply. This would be x to the negative 18th. But of course, you can't write that. I wrote superscript by accident. Whoops. Negative 18. So of course, you would rewrite this using negative exponents rules. It would be 1 over x to the 18th. Okay? I hope you don't mind that I wrote a horizontal fraction. For 73, this is m to the 0th. Well, that m to the 0th equals 1. So 1 times 5, this would equal just 5. For this term, we're going to multiply all of these and then do some simplifying if necessary. 3 times negative 5 is negative 15. X to the second times x is x to the third. And y to the third times y to the 8th, that's y to the 11th. And that is all we can do with that one. There's no negative exponents. Negative coefficients are always okay. For this one, 75, we're going to raise everything inside here to the third power. So basically, we're going to multiply any exponents. 3 to the third is 27, so we'll start with that. C to the 4th times 3 is c to the 12th. And then d to the 5th times 3, that's d to the 15th. For 76, we have 6x to the 10th y to the 2nd over 2x to the 7th y. So here we're going to use the quotient rule. We're going to have 3, because 6 divided by 2 is 3. X to the 10th divided by x to the 7th is the difference in the exponents, so it's going to be x to the 3rd. And then y to the 2nd times y, or divided by y would just be y. I think that's a 2. I don't think that's a 3. If it was a 3, it looks like a 2 to me. Yeah, it's a 2. Okay. Now, for 77, we have 216 to the 1/2. That means that we're going, and it looks like a 3. Now that I'm looking at it, it does kind of look like a 3. Maybe this is a 3. And if that is the case, we're going to make that 2. It looks like a 3 to me. So 216 to the 1/3 means that we're going to be doing the cube root of 216. So writing that in radical form would look like this. And then we would write an index of 3 right here. I should switch to my thinner pen, but that's okay. So the cube root of 216, what number times itself 3 times is equal to 216? The answer is 6. Okay? All right, we're almost there. My new bank is offering great rates on new savings accounts. The accounts manager tells you they're offering 7.5% interest per year. Oh, I want that account. That's a lot of interest. You want to invest $18,000. Define the variables, write an equation for the account balance. Well, if you're investing this and it's regular interest, this is going to be an exponential function. So the variables in this case, we don't know the time. In this case, x would be equal to time in years of the account. And the equation here would be y equals our starting amount, which is 18,000. We want to use AB to the x form. So I'm just writing that just to remind you. And then A is the starting amount, which is 18,000. And then our interest is 7.5 per year. That's a percent increase. So we'd use 1.075, 1 plus r, right? And then that would be raised to the x power. Okay? So completing the table below. So here we would just kind of plug in these numbers into a calculator. You can use the table of values if you just plug the function into your y equals and then use the table feature, which is second graph if you are using a standard TI-85 calculator, T84 calculator, excuse me. 18,000, I'm putting it in right now to give these values, raised to the x, and then go to second table. Standard setting on my table would be 0, starting at 0. I have to scroll up a little bit, but that's okay. And then here, the numbers we're going to get are 19,350. For number 1. For number 2, we're going to, for year 2, we're going to have $20,801.25. And for year 3, we're going to have $22,361.34 in our account. Okay. The growth rate here is 1.075, and the y-intercept is 18,000, our A and B values. After 10 years, again, I'm using the table feature on my calculator to get this number, but you also could just plug in 10 here and use your calculator to get that. You will have in your account $37,000, excuse me, $37,098.57, just about. Okay. Next question. We have a local country club. They have a tennis tournament. The tournament starts with 128 players. During each round, half of the players are eliminated. So if we start with, after round 1, at round 1, we would have how many players left? So in this case, the first round, we'd have 128 players. During each round, half of the players are eliminated. I just want to make sure that I'm using the right A value here. If they say round 1, do they mean number of players that are left or number of players that are in that round? So in this case, I'm going to use the idea that there are a number of players that are in the round. That was going to change our function just a little bit, but that's okay. And then the next round, half of the players would be eliminated. So after 64, you'd have 32. After 32, there'd be 16. Okay. What type of function is represented by this particular thing? Oh, we have to graph it too. So let's graph that real quick. Let's use tens here. So this is going to be 50 right here. I'll lower the font just a little bit. That'll be 50 here. Right there for our x-axis, that will be 100 here. Okay. So, and then down here we'll go by ones. So 1 here, this will be 5 here. Okay. All right. So where will these points be? Well, the first point here is going to be just about 130, but right there. The next one, 64, is going to be right about here. Next one's 32. That's going to be right about here. The next one's going to be 16, and that's going to be right about here. Okay. And of course that would continue. So this curve, I'll do my best to draw what this curve would look like. It would kind of look like, ugh, that's terrible. I'm not going to be able to draw a very good curve for this. It's the mouse. This is kind of hard. Okay, so it's going to be something like this. It's going to flatten out, and it's going to go like that. Okay, something like that. Now, and there's our arrowheads. What type of function is represented by this situation? This is decay, okay? Exponential decay. Okay, the y decreases as x increases. Write an explicit rule to explain this relationship between the round number of players. Now, for this one, I'm going to show you the function first, and I'll explain what is going on with each one. Okay. Now, the reason why we are using 256 is because the value that we would get here for 0 should be 256, because after 1, it should be half of that. So if we're using the fact that even though, yeah, we're not starting with 256 players, if there was a, quote, 0th round, according to the way I've answered this question, this is what you would have. So the other interpretation would be that if it's after the first round of the tournament, how many are left, then technically this should be 64, 32, 16, and 8. But again, they're not clear about which of these two you would say. So I'm going to say that that's be the value that you want to use. And note, if I plug in the round number, 0.5 to the first is 0.5, then times 256 is 128. Now, if you didn't know that, or if you weren't sure how to get that number, you can just use the format of y equals ab to the x and solve for a. That's one option. You also could just look at this table and see, well, if you're dividing by 2, what would you have to divide by 2 to get 128? You can just multiply that by 2 to get 256. So after round 6, if you plug in 6 or just use the continuation of the table, you will see that you'll have 4 players left. Okay. So again, now that I look at this, the way that they've explained this particular question, I'd venture to say that's the first one. It actually would be 64, 32, 16, and then 8. So because after round 6, there's technically 2 players left after round 6. Okay. So I believe the way they've worded this function, which is unclear, I would say that they mean after the round is played, how many players are remaining. So technically, I'll change the color just to show you here. I don't want to leave the old discussion up as well. 64. Oops, I thought I was changing the color. 64, 32, 16, 8. Okay, so technically those would be your numbers, which means your function would actually be y equals 128 times 0.5 to the x. Okay, so I would say that if this kind of question was on the test, I would say that either of these answers would be acceptable based on the way the question is worded. Okay. Last, we have 3 questions to go. We're almost there. Whether the function models exponential growth or decay, find the percent increase or decrease. In this case, so we have initial value of 3. Let's change this back to black. Value of 3. Growth or decay. In this case, it's decay. And then what is that rate of decrease? This is a percent decrease. So it would be 1 minus 0.23. That is a 77% rate. Okay. Initial value here is 0.5 or 1.5. The fact that the b value is 1.7 models growth. And then the rate of increase is 1.7 minus 1, so that's 70%. Okay. And I would say increase. And let's say for this one, let's say decrease as well. Okay, just to be consistent. All right, final question. Now, this one here's a bunch of things to do with this particular thing. We're going to write recursive and explicit functions to go with input-output tables or fill in input-output tables as needed. So our first function, I'll do a couple here. Our first function here is looks like a linear decrease. We're going down by 2 every time x goes up by 1. So the explicit function here would be y equals negative 2x plus 10. The recursive function would be to start at 10, decrease by 2, okay, for the next term. All right, and then we have here okay, so the next term. Okay, then we have here, we have 4 times 5 to the x for our explicit function. So our y value, our output values would be as follows. 4, we would have 5 to the x, 5 to the first, times 4. So we're going to be increasing this by 5 times each time. So this is going to be 100. This will be 500. This will be 2,500. Oops, with an extra character there. Okay, and then the explicit function here, start at 4, multiply by 5 for the next term. Okay. Now, in this case here, they tell us the first term is 800, excuse me. To get the next term, multiply by 1/2. Well, here, we're going to go y equals 800 times 0.5 to the x. And then same deal here, just fill in the table. 800, cut each number in half. This is going to be 400. Whoops. 200. Hello. Trying to get the cursor to go. There we go. 200. And then 100. And then 50. Okay. All right. Here we have another table of values. Starting at 4, going to 24, 144. This looks like a times 6 increase. So our explicit function would be y equals 4 times 6. 4 times 6 to the x. Okay? And then here we're starting at 4, multiply by 6 to get the next term. Of course, I just realized I have a typo up here as well. Try again. Okay. And our final function here, we have a linear function, negative 0.25x plus 3. So our value here for this is going to be 3. And then we're going to be going down by 2,500. So it's going to be 2.75 for the next one. And then 2.5, 2.5, 2.25. And then 2. Okay? And of course, for recursive, just writing it out in words, start at 3, decrease by 0.25 to get the next term. That's it. Okay? So that concludes the algebra final exam review. You should be well prepared for this. If you have questions or comments, or if you would like anything else explained that I did not explain adequately enough, or if you like a different interpretation, whatever you got, please leave a comment. And hope you enjoyed the video, and good luck on your exam.